Hello there, and welcome back to the Sleep Science, where you get to lie back, sink into the pillows, and let me do the wandering for you. Tonight's little journey begins out in the dark, with you floating between galaxies as though your body has been turned into a feather, except without the awkward flapping. You drift forward, not with rockets or wings, but with that quiet certainty that this is a dream space, a thought experiment made soft enough to rest inside. The stars around you shimmer in pale clusters, and the Milky Way itself looks less like home and more like a hazy bridge behind you. The sensation is oddly soothing, though I should warn you, if you were actually here, with no spaceship, no suit, and nothing but raw cosmic radiation nipping at you, well, you probably wouldn't survive this. But hey, it's just us, safe in narration land. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you're listening right now, I'd love for you to drop a quick comment with your location and the local time where you are, because something about seeing little notes from every corner of Earth makes this whole sleepy science adventure feel like a shared campfire under the stars. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You continue drifting. Galaxies stretch like pearls on invisible strings, a web of light and silence spanning hundreds of millions of light years. You can almost hear the hum of it, though sound doesn't travel in the void. It's more like the suggestion of a song, the kind of tune your mind writes when it sees so much beauty that it needs a soundtrack. And as you float, you begin to wonder, what's beyond all this? Where does it stop? Is there a curtain we eventually bump into, like the painted wall at the end of a theatre set? Astronomers have tried to answer that, of course. In the 1920s, Edwin Hubble looked through his telescope and noticed something peculiar. Distant galaxies were red-shifting, their light stretched toward the longer, redder wavelengths. That stretch told him they were rushing away, and not just from us, but from each other too. The whole universe was expanding, like dough rising in a cosmic oven. This discovery gave us a fact as solid as bread crust. The universe has no fixed edge, the way a wall has an edge. Instead, every point is flying away from every other point. But still, there has to be something on the other side, right? After all, even rising dough has the bowl around it, and that thought is what lingers in your chest as you gaze outward, further and further, until the spiral arms of galaxies blur together into a milky fog. Historians still argue whether early civilizations thought of the sky as infinite or finite. Some claim that the Babylonians believed the heavens were like an ocean dome covering the earth, while others say Greek philosophers flirted with the idea of endless space far earlier than we give them credit for. Either way, humans have always been tugged toward the same uncomfortable curiosity that now tugs at you. What if you could just keep going? Your mind drifts to stranger details. Did you know the ancient Egyptians once used crocodile dung as a kind of sunscreen? Entirely unrelated to galaxies, sure, but it's one of those reminders that humans have always stared at their world, tried to explain it, and sometimes come up with ideas that are, let's say, questionable. That same restless urge is what pushes modern astronomers to wonder about the edges of the cosmos. Maybe in 2,000 years, people will look back at our theories and chuckle the same way we chuckle about croc dung SPF 5. The stars ahead seem to thin, but not because space is running out, more because your eyes can't keep up with the sheer scale. Beyond the visible galaxies lies an ocean of blackness, and you imagine yourself brushing fingertips against an invisible curtain. It feels like velvet, cool and rippling. A stage backdrop stretched across infinity. You sense something beyond it, though it doesn't give way. Here, in this imagined place, you picture the universe like a balloon. Not a party balloon that squeaks when you rub it, but one made of shimmering fabric. Every galaxy you've seen is a dot drawn on its surface, and as the balloon expands, the dots all move apart. But what lies outside that balloon? Is it a room, a child's hand, or is it nothing at all? Science has no firm answer, and that's part of why this question feels so deliciously unsettling. It's like staring into a locked treasure chest. You know there's something inside, but you can't peek. The universe's other side could be another universe or endless mathematical space, or maybe maddeningly a concept we aren't wired to understand. You shift slightly, as though reclining deeper into this imaginary void. The air, if there were any, would be sharp with cold, but here it feels like velvet silence. You realise you're not racing toward the edge of everything. Rather, everything is racing away from you. It's a subtle difference, but important. Galaxies don't sit still while the universe stretches like elastic, they're caught in the stretch. You're not outside the action, you're inside the dough itself, rising right along with it. Still, the mind craves edges. You want a wall. You want something solid to press against, even if it means bruises. It's like when you're trapped in a fog and you stretch out your arms just to feel a tree, a rock, anything. The idea that space might just keep going without an outside feels slippery, like trying to hold water in your palms. And yet that slipperiness is what makes it fascinating. Some cosmologists say that asking what's outside the universe is like asking what's north of the North Pole. It sounds reasonable, but it's actually nonsense because the coordinates themselves bend into a closed system. If that frustrates you, good, you're in excellent company. The brightest minds have wrestled with the same irritation for centuries. As you float further, you imagine the cosmic microwave background, the faint afterglow of the Big Bang spilling across space like a pale watercolour wash. It's real, detectable even today, a kind of ghostlight humming at a steady temperature of 2.7 Kelvin. Think of it as the faint hiss you hear when an old television loses signal. That hiss is literally the after-echo of creation itself, still bouncing around, still filling every corner. And when scientists map it, they see patterns, ripples, waves, spots that tell them about the very early universe. But none of it tells them what's beyond. And here's where your imagination can go wild. You picture the universe not as a balloon, but as a stage curtain, and you're peeking at the seam. If you could slip your fingers between the threads, what would pour through? Light from another cosmos? A rush of different physics, where gravity pulls sideways and time ticks in jagged leaps? Or maybe nothing, no time, no space, no anything. Just a quiet absence that we can't even picture without projecting our own rules onto it. The quiet hum of your fan in the room back on Earth suddenly feels like an anchor. It reminds you that this isn't meant to be overwhelming. This is bedtime fuel, not an exam. The universe's edges are unknowable. But that doesn't make them frightening, it makes them oddly comforting. There's something soothing about the idea that the biggest mysteries remain out of reach, tucked safely away so we can toy with them without burning our hands. And maybe that's the secret. You don't need to know what lies on the other side of the universe in order to drift here, in this in-between place, eyes closed, mind softening. Just imagining the possibilities, the balloon, the curtain, the infinite dough, the nonsense questions, gives your thoughts enough to play with until sleep tugs them down into dreams. For now, you rest against the invisible boundary, staring at the velvet dark. Somewhere, galaxies are still pulling apart, stretching further and further. Somewhere, the afterglow of the Big Bang still whispers. And somewhere, deep in your chest, curiosity hums like a lullaby. You don't need the answers tonight. You only need the wondering. You push further, leaning into the dark fabric of space, and it begins to dawn on you, literally, because the glow of distant galaxies smudges into faint streaks, that there's a hard limit to how far your gaze can travel. Not because you've hit a wall, but because light itself is maddeningly slow. Well, slow by cosmic standards. 300,000 kilometers per second is fast enough to make any sports car look like it's crawling through rush hour traffic, but across billions of light years, even that velocity feels like molasses dripping down a cold window. So you float, peering into the abyss, and realize you're not seeing galaxies as they are now. You're seeing them as they were. Each patch of light is a postcard mailed billions of years ago, finally arriving. That spiral nebula. Maybe it's gone by now, shattered into stardust. You're not looking at the present. You're staring at a library of cosmic history, light delayed like the world's slowest Wi-Fi connection. Astronomers call this our observable universe. Not because it's all that exists, but because it's all we can see. Beyond about 46 billion light years in any direction, light hasn't had enough time since the Big Bang to reach us. That's the limit. The speed of light is the jailer, and you're the prisoner staring through bars made of physics. The term observable universe is deceptive though. It makes it sound cozy, like a snow globe with neat edges. But the truth is you can never step outside it. You live forever inside this glowing cage of photons, unable to peek beyond the horizon no matter how big a telescope you build. The strange part? The observable universe is already bigger than you'd expect. You might assume that if the cosmos is 13.8 billion years old, we could only see 13.8 billion light years in any direction. But space has been stretching like taffy the whole time. That means the farthest light we can detect actually comes from regions now 46 billion light-years away. The math gets squishy here, but the gist is that expansion cheats the numbers, gifting us a universe much bigger than its age alone suggests. Historians still argue whether Albert Einstein was truly convinced by his own equations when he first played with the idea of a finite yet unbounded universe. Some say he added his infamous cosmological constant out of stubbornness, unwilling to believe in expansion until Hubble forced the issue. Others think he's secretly enjoyed the paradox, that space could be curved back on itself, endless yet closed, like a sphere with no edges. You can picture him pacing in his socks, chalk dust on his coat, muttering in German about the speed of light being both friend and tormentor. Meanwhile, you keep gliding, caught between awe and impatience. Why should light get to decide how far you see? Why should photons hold the keys to the horizon? You imagine trying to negotiate with the universe. Hey, I've been very patient. Could I maybe get a sneak peek at what's just beyond the observable bubble? But the cosmos doesn't bargain. The rules are the rules, and yet every rule invites a workaround. Astronomers are clever that way. They don't just look at light, they study neutrinos, ghostly particles that slip through matter like it's barely there. They chase gravitational waves, ripples in space-time itself, as though the universe were a pond and distant collisions were stones tossed in. These messengers travel differently, maybe revealing secrets photons can't carry. But even so, the cage holds. The edges stay blurry, it's funny in a way. Humanity has invented telescopes that can see about planets hundreds of light-years away, can measure the faint glow of baby galaxies forming, when the universe was less than 1 billion years old, and can even detect the afterglow of the Big Bang itself. And yet, beyond 46 billion light-years, nothing. Just a shrug, a locked door, a cosmic no trespassing sign. The thought makes you chuckle softly, which feels odd in this quiet dreamscape. Imagine standing at the edge of the Grand Canyon, taking in its immensity, only to be told that actually, what you're looking at is just a scaled-down replica, and the real canyon extends far, far past the fog, but you'll never ever see it. It's maddening and also kind of comforting. There's a certain elegance in not being allowed to know everything. Keeps the game interesting. And the quirks don't stop there. Did you know that in the 17th century, astronomer Ola Römer first measured the speed of light by watching Jupiter's moon Io duck in and out of the planet's shadow? He noticed the timing shifted depending on Earth's position in its orbit, as if the light had been delayed on its journey. That's right, one of the biggest constants in the universe was uncovered because someone was basically timing celestial peekaboo. It's the kind of discovery that makes you grin. The grandest truths sometimes hide in the simplest games. As you hover, your imagination paints the observable universe not as a cage, but as a glowing snow globe. Inside, galaxies spin, collide, and bloom like fireworks frozen mid-burst. Outside, blankness. Or not blankness, something perhaps, but something you can never touch. You press your hands against the curved glass, breath fogging up the barrier, and you swear you see shadows moving beyond. Maybe that's just your sleepy mind playing tricks, but maybe not. Some scholars whisper about a cosmic event horizon. It's similar to a black hole's event horizon, the point beyond which no light can escape, except in this case it's not a collapse sucking things inward, but expansion flinging them away. Galaxies on the far side of this horizon are moving faster than light relative to us, not because they're breaking physics, but because space itself is stretching beneath them. To you, it feels like watching a ship sail past the curvature of the Earth. It hasn't stopped existing, you've just lost the ability to follow. Historians still argue whether future technology might ever cheat that boundary. Some daydream about hypothetical particles travelling faster than light, or wormholes punched through space-time like trap doors. Others roll their eyes, muttering that such speculation belongs in comic books, not journals. But in truth, nobody knows. The observable cage may be permanent, or it may one day crack. You tilt your head, imagining a far future explorer peeking out, finally seeing what you're only guessing at tonight. The cage doesn't feel cruel, though. It feels oddly parental. The universe gives you just enough to ponder, to marvel, to keep you humble. It keeps its secrets tucked away like a bedtime story you're not old enough to hear yet. And you're content to drift here, tracing your fingers along the glowing boundary, feeling the vibration of light's long, stubborn journey. At some point, you realize how drowsy the repetition makes you. The phrase speed of light hums like a mantra, steady and soothing. You picture photons as tiny lanterns, bobbing toward you across the vast sea of space-time. Some arrive quickly, like messages from nearby stars. Others are ancient, their senders long gone, carrying gossip billions of years old. And together, they weave the tapestry you call the observable universe. A cage, yes, but a glittering one. The soft hum of your fan back on Earth grows louder in your awareness, reminding you that you're not actually trapped in space. You're just tucked in, warm, breathing slow, eyes closed, imagining what lies just past the horizon. The cage is only a boundary of knowledge, not of experience, and that means you're free to wander as far as you like. You linger at the edge of your observable cage, fingertips pressed against its glowing glass, when something curious brushes your ears. Not in reality, of course, but in that dreamy way sound sneaks into your imagination. It's a hiss, faint and steady, like static on an old radio dial. You tilt your head. There it is again. Not loud, not startling, just persistent, as if the universe itself were whispering in the background. That hiss is older than any star, older than any galaxy, older even than the atoms in your body. It is the after-echo of the Big Bang itself, still drifting through space like a lullaby that refuses to end. Astronomers call it the cosmic microwave background radiation, or CMB if you want to sound like you're in on the secrets. Imagine the universe when it was just a newborn, dense, hot and glowing like a furnace. About 380,000 years after the Big Bang, the cosmos finally cooled enough for atoms to form. Before that, it was an opaque soup of charged particles, light bouncing around like a toddler in a sugar rush with nowhere to sit. But once the universe settled down, light could travel freely for the first time. That first freedom is what you're hearing now. Photons, stretched by billions of years of expansion, humming at microwave frequencies that wrap around you like a blanket of static. It's funny to think that your television, back in the days before streaming, sometimes picked up this very hiss. Twist the dial to a dead channel, and maybe 1% of that static fuzz was literally the Big Bang, whispering through your living room. Most people cursed at it, smacked the side of the TV, or adjusted the rabbit ear antenna. Little did they know they were brushing against the oldest message in existence. Historians still argue whether Arno Penzias and Robert Wilson, the two radio astronomers who stumbled on the CMB in '64, actually believed their instruments were broken at first. The story goes that they thought the noise in their giant horn antenna came from pigeons nesting inside, leaving droppings that they politely called white dielectric material. They scrubbed it, cleaned it, chased the birds away, and yet the hiss persisted. Only later did they realize they weren't listening to pigeons, they were eavesdropping on creation itself. Imagine discovering the dawn of everything because some stubborn static refused to leave you alone. You lean back in the void and let that hiss seep into your imagination. It isn't sharp, not like a ringing phone. It's soft, almost gentle, a steady shh that feels like the cosmos telling you to quiet down, breathe slow and drift. It feels like white noise designed by the universe itself to help you sleep. And yet, tucked inside that noise are patterns. When scientists map the CMB with exquisite precision, they don't see a perfect smooth glow. They see tiny ripples, temperature differences of just a few millionths of a degree. Those ripples are the fingerprints of early density fluctuations, slight clumps where matter gathered a little more here, a little less there. Over billions of years, those tiny wrinkles grew into galaxies, clusters, stars, and eventually, you lying in bed wondering about all this. It's wild to think that the static in your imagination contains the seeds of every planet, every flower, every joke, every love letter ever written. The CMB doesn't just whisper history, it also sets boundaries. By measuring it, astronomers can estimate the age of the universe, its overall shape, and even how much dark matter and dark energy must exist to explain the patterns. It's like reading tea leaves left over from a cosmic teapot. Of course, historians still argue whether these measurements are as precise as we claim. Some believe there are hidden anomalies in the CMB data, like the so-called axis of evil, a suspicious alignment of temperature variations that seems too strange to be random. Others say it's just statistical noise, nothing more. But you can't help but imagine, what if that hiss carries a secret message we haven't learned to decode yet? Speaking of quirky tidbits, here's one to chew on. In the 1990s, when NASA's COBE satellite first mapped the CMB with unprecedented clarity, the lead scientist George Smoot famously said, "If you're religious, it's like looking at God." The quote spread like wildfire, partly because of the drama, partly because of the sheer awe it inspired. Imagine being the person who unveiled the baby picture of the universe, a snapshot not of a star or a galaxy, but of existence itself when it was still swaddled in plasma. You can almost picture Smoot holding up that grainy map the way parents hold up an ultrasound photo. Look, it's the cosmos, it has your nose. And here's a lighter aside, because we need those. If you could somehow bottle the CMB and serve it at a coffee shop, it would be the blandest drink imaginable. At a uniform temperature of 2.7 Kelvin, it's barely above absolute zero. You'd sip it, frown and say, "Yep, tastes like empty space. Not exactly Starbucks material, but definitely the universe's signature brew." You shift again in your imaginary float, the hiss still wrapping you like a gentle tide. It's easy to forget that this sound has been travelling for nearly 14 billion years, uninterrupted, untouched, unwavering. Everything else has changed. Stars born and gone, galaxies colliding, civilizations rising and crumbling, but this radiation has stayed faithful, a constant companion threading through all of time. There's something profoundly soothing about that consistency. It makes you feel less like a speck and more like part of a song that's been playing since the beginning. Your thoughts wander, as they often do at this hour, to what the hiss means. Is it just noise, or is it evidence of something more? Some fringe thinkers like to imagine that the CMB carries an intentional pattern, maybe even a code left by whoever, or whatever, sparked the Big Bang. Others scoff, insisting it's just physics, no poetry required. Historians still argue whether science and philosophy should even overlap on such questions, but here, in your drifting state, it feels perfectly natural to let the two blur together. Why not treat the hiss as both physics and poetry, both data and lullaby? It helps that the sound reminds you of simpler moments. A seashell pressed to your ear, a rainy night with static on the radio, the hum of an old refrigerator in the background of your childhood kitchen, familiar, unremarkable noises that felt safe. The universe, it seems, has been making its own background noise all along, steady, patient, eternal. The more you listen, the more your eyelids feel heavy. The hiss isn't demanding, it doesn't rush, it doesn't insist on being solved right this second. It just is. And in a world full of clamour and chatter, there's a strange peace in that. You could float here forever, letting the after-echo of creation itself rock you towards sleep, like a mother shushing a restless child. Somewhere far away, astronomers are still refining their maps, still analysing the ripples, still chasing the tiniest whispers hidden in the background radiation. They debate, they argue, they publish papers with equations that look like spaghetti. But for you, here and now, the science boils down to this. The universe left its baby monitor on, and you're still listening. You close your eyes, breathing slow. The hiss fades not because it stops, but because you've merged with it. You are part of the static now. One thread in the long cosmic hum. It stretches behind you into the past, ahead of you into the future, and all around you in every direction. You don't need to decode it. You don't need to understand it. You only need to let it lull you deeper. You've been floating in that steady hiss, lulled by the cosmic background like it's the world's oldest lullaby when the thought sneaks in, how did all of this cage of light, this static, this grand theatre of galaxies ever spread so far, so quickly? The Big Bang gave you the spark, sure, but the size of the universe today is far too vast for simple expansion alone. Ordinary growth wouldn't cut it. It would be like blowing up a balloon with a single lazy puff and expecting it to fill a football stadium. Something stranger had to happen, something wild enough to stretch space itself, like gum pulled too far. And that's where inflation waddles in. Cosmic inflation, that is, not the kind that makes bread expensive, though let's be honest, that one feels almost as mysterious sometimes. Inflation theory suggests that in the tiniest fraction of a second after the Big Bang, less than a trillionth of a second, the universe expanded faster than the speed of light. Not objects moving through space, but space itself stretching. Imagine blowing up a balloon and, before you can even blink, it jumps from the size of a grain of sand to something bigger than the galaxy you left behind. That's the balloon trick the cosmos pulled off. The best part? It happened so fast that nothing, no light, no signal, no warning could keep up. The universe doubled in size and then doubled again and again, repeating this mad growth spurt dozens of times in less than a heartbeat. By the time inflation calmed down, the universe was unimaginably vast, smooth, and uniform. It's like the cosmos ironed out its wrinkles with a hot press, leaving only faint ripples behind for you to study billions of years later. Historians still argue whether the first hints of inflation were treated with enough seriousness when the idea surfaced in the 1980s. Alan Guth, the physicist often credited with developing the theory, once joked that he scribbled his breakthrough on a yellow legal pad and immediately added the note "spectacular realization" next to it. But colleagues at the time weren't always sure whether it was genius or madness. Even today, some remain skeptical. Did the universe really balloon that fast, or is inflation just a convenient patch to fix our equations? The debate hums on. You drift in your dreamlike space, picturing it unfold. One moment, the cosmos is smaller than a proton, dense and chaotic. The next, it inflates so abruptly that distances between points stretch faster than light can travel. You feel it tug at your bones, though not painfully, more like being gently pulled in every direction at once, an endless yoga stretch with no resistance. The galaxies you saw earlier? They weren't even concepts yet, but the seeds of their existence were sown in those wild fractional moments, and the evidence for this balloon trick hides in the very hiss you were listening to earlier, the cosmic microwave background. Those tiny ripples, those subtle differences in temperature across the sky match almost perfectly with what inflation predicts. Without inflation, the universe would be a patchwork mess, clumpy and uneven, galaxies huddled in some spots and absent in others. Instead, you see smoothness, a strange uniformity that doesn't make sense unless something ironed it all out. Inflation was the iron. Here's a quirky tidbit for you. Some models of inflation suggest that while our universe ballooned, it might not have been the only one inflating. Picture a pot of boiling water. Bubbles appear, expand, and float away from each other. Our universe could be just one bubble in an infinite froth, each with its own physics, its own rules, its own wild variations. Somewhere out there, another bubble might be expanding right now, full of stars that burn green or laws of gravity that make no sense to you. The thought tickles like champagne fizzing in your nose. You can't help but grin at the absurdity. Imagine trying to sell that idea to someone in the 1600s. Oh, by the way, the universe inflated faster than light right after it was born, and there might be other universes out there too. They'd probably pat you on the head, hand you a candle, and tell you to lie down. Yet here you are, floating at the edge of sleep, seriously entertaining the notion. Progress, I suppose. The fan in your room hums again, a steady reminder that you're safe, tucked in, not actually riding a cosmic balloon. But your imagination doesn't want to let go. It conjures the image of the universe as a bright, stretching fabric. At first, it's a small scrap of cloth, wrinkled and tight. Then, with a sudden tug, it stretches out, flattening, smoothing, expanding, until it's too big to measure. You glide across its weave, running your fingers along the threads, each one glowing faintly with potential. And then you pause, considering the weirdest part of all. Inflation wasn't just fast, it was absurdly fast. So fast it feels like a cosmic prank. Faster than light expansion sounds like breaking the universe's own rules. But here's the trick, it didn't. Objects can't move through space faster than light, but space itself can expand as quickly as it likes. It's like saying the highway beneath your car is stretching while you sit still. The rules bend, but they don't break. Physics has loopholes, and the universe knows how to exploit them. Historians still argue whether we'll ever detect direct proof of inflation. Some believe that gravitational waves, ripples in space-time left over from that rapid stretching, should still echo faintly in the universe. In 2014, one group of scientists thought they'd found them, announcing to the world that they'd glimpsed inflation's fingerprints. Headlines screamed, the scientific community buzzed. Then awkwardly, it turned out to be dust. Yes, interstellar dust masquerading as proof of cosmic origins. Imagine telling your colleagues you mistook dirt for the birth cry of the universe. Ouch. Still, the search continues, and you can't help but admire it. Humans sitting on a small blue planet trying to measure events that happened a trillionth of a second after time began. It's like listening for the echo of a match strike in a storm, yet somehow they're getting closer. A random thought drifts by. If the universe inflated so suddenly, does that mean time itself inflated too? Was there even a before to talk about? Philosophers love to poke at this sore spot. Some say before the Big Bang is meaningless because time was born with space. Others speculate about previous cycles, previous universes feeding into ours. Historians still argue whether such speculation belongs to science or metaphysics. But as you drift, the debate feels less like an argument and more like an open invitation to wonder. You sigh, a slow, sleepy exhale. Inflation makes your head spin, but in the best way. It's not a threatening thought. It's like watching a magician pull scarves from a hat, endless fabric where none should exist. And the best part? You don't have to solve the trick tonight. You only have to enjoy the spectacle. The stars around you blur, not because they're fading, but because your eyelids are heavy. You picture the balloon still stretching, still growing, though the actual inflation ended long ago. Expansion continues, slower now but steady, like the universe taking long, relaxed breaths. You imagine resting your head on its chest, hearing those breaths rise and fall steady and eternal. For now, you let go of the need to understand. Inflation may be one of the strangest ideas in all of cosmology, but tonight it's simply a story, balloon inflating in your mind's eye. You're content to float with it, to let the fabric of space carry you, smooth and vast, stretching gently beneath your fingertips. You've stretched with the balloon of inflation, felt the universe tugging at your edges like fabric pulled taut, when suddenly you realize something sobering. No matter how far you drift, no matter how wide the balloon stretches, there will always be a line you cannot cross. A boundary, not painted in bright neon or guarded by cosmic security, but set by the simplest of rules. Light only travels so fast, and space itself is expanding beneath it. That line, faint and absolute, is the cosmic horizon. Picture it this way. You're standing on a beach at dawn. The horizon glows faintly, a distant line where sea meets sky. You know the world continues past that point, but your eyes can't reach it. The cosmic horizon is like that, but instead of miles of ocean, it's billions of light years of expanding space. Beyond it, the galaxies still exist, still burn, still swirl in their endless dances, but they're lost to you forever. Their light will never catch up. You'll never see them, never even know exactly what's out there. The universe, generous as it is, draws the curtain just so far and then leaves you to imagine the rest. This isn't just theory. Astronomers can actually calculate the horizon's limit, about 46 billion light years in every direction. That's the reach of our observable universe, the bubble inside which every star and galaxy will ever see must fit. Beyond that, everything slips away faster than light itself. It isn't that those galaxies are breaking cosmic speed limits, it's that space between us and them is stretching too quickly, carrying them off like leaves on a river rushing out of reach. Historians still argue whether calling it a horizon is the best metaphor. Some prefer to compare it to a prison wall since it truly limits what you can know. Others call it a window, fogged at the edges. A few even liken it to a mirage, because what you think you see near the limit is warped and redshifted into almost nothing. But horizon works well enough. Everyone knows the feeling of gazing at a distant line, aching to step beyond it. You hover there now, weightless, at the edge of vision. Galaxies smear into faint red streaks. Their light, stretched to longer and longer wavelengths by expansion, looks like tired runners dragging their feet. You reach out instinctively, trying to cup the last photons before they vanish into black. It's no use. The horizon swallows them, leaving only darkness beyond. But don't think of it as a wall. Think of it as a promise that the universe is larger than you can ever know, full of mysteries safely tucked out of reach. There's comfort in limits, strange as that sounds. You can't burn yourself on the fire if it's always beyond the hill. You can't drown in the ocean if the shore is as far as you're allowed to go. In some quiet way, the cosmic horizon is less a barrier than a bedtime boundary, tucking you in with the knowledge that curiosity can stretch but not break. And yet, your imagination refuses to sit still. It pokes at the horizon, rattling it like a locked gate. What lies beyond? More galaxies, more clusters, more webs of stars tangled in dark matter's invisible net. The universe doesn't stop just because you can't see. It sprawls endlessly, repeating its patterns of birth and death in realms forever hidden. You can't help but smirk at the irony. Existence itself is out there, but you'll never get the receipts. It's like the universe is playing the world's longest practical joke. Here's a quirky tidbit to keep you company. Some scientists speculate that beyond our horizon, the universe might look drastically different. Because of inflation, distant regions may have settled into entirely different conditions, different densities, maybe even different laws of physics. Imagine drifting past the line and suddenly finding a cosmos where gravity pushes instead of pulls, or where stars never form at all. You wouldn't last long, of course, but the idea is oddly exhilarating, like peeking into alternate realities without leaving your pillow. As you float, the fan back in your room hums again, a soft imitation of cosmic background noise. It blends with the imagined silence of the horizon, reminding you that the real universe isn't quiet. Out here, galaxies roar with explosions, stars crackle with nuclear fire, black holes devour matter with terrifying hunger. But distance and expansion mute it all, leaving you with only this hushed edge. You're like a listener sitting in the back row of the largest concert hall ever built, hearing only the faintest echo of the symphony. Historians still argue whether humans will ever invent a way to cheat the horizon. Wormholes, faster than light travel, clever tricks with quantum entanglement, all are whispered about in serious papers and science fiction alike. For now, though, it remains firm. You're trapped inside your bubble, no matter how hard you wish otherwise. And maybe that's for the best. Some secrets are meant to stay hidden, not because they're dangerous, but because they keep wonder alive. You find yourself thinking about old myths. Cultures throughout history imagined horizons of their own, edges of oceans where sea monsters lurked, skies that bent like domes, worlds bounded by walls of fire. To them, the unknown lay just past the horizon. To you, it's the same, only scaled up to cosmic size. The details change, but the feeling doesn't. Humans have always pressed against the limits of vision, always asked, what's beyond? And the universe, sly as ever, has always answered, more than you can handle. The galaxies closest to the horizon fade now, their light stretched into invisible infrared, then microwave, then nothing your eyes could ever catch. You're left with darkness, velvet and infinite. And yet the darkness isn't empty. It teems with possibilities, with secrets you'll never chase down. That thought should frustrate you, but instead it soothes. You don't need every answer to sleep well. Sometimes it's enough to know the questions exist, so you let the horizon be what it is, a soft edge, a reminder that your universe is both vast and finite. You recline into the silence, listening to the faint hum of photons that can reach you, knowing countless more slip away unseen. Beyond the line, existence continues its endless sprawl, a mystery wrapped in distance and time. And you're safe here, drifting in the bubble you're allowed, rocked gently by the boundaries of light. You rest against the soft dark of the horizon, that velvet line where galaxies fade and silence deepens, when suddenly your imagination takes the next leap. What if that horizon isn't the end at all? What if beyond it all, the universe doesn't just keep sprawling in endless sameness but gives way to other universes entirely? You picture them as bubbles in a vast frothing sea, each ballooning into existence during inflation, each swelling and floating until they bump elbows with one another. Ours is just one bubble, you realize, drifting in an eternal foam. The idea is called eternal inflation. If inflation can happen once, maybe it happens endlessly, with patches of space ballooning into bubbles that become full-fledged universes. Our cosmos might not be special. It might just be one bubble among countless others, most forever cut off from us by space expanding too quickly for any signal to bridge the gap. That horizon you touched earlier? It might just be the thin wall of our bubble, pressing against the bubbles beyond. Historians still argue whether this is science or just daydreaming dressed up in equations. Alan Guth and Andrea Linde, the architects of inflation theory, both entertained the possibility of multiple bubbles, but critics point out that if we can never see them, how can we ever prove they exist? It's like debating the number of unicorns in a forest you'll never visit. Yet the math teases you with possibilities too tempting to ignore. You picture yourself drifting to the outer skin of our bubble. It shimmers like soap film, stretched thin, delicate but unbroken. Your hand hovers above it, and for a moment you imagine dipping through, slipping into another cosmos. Would you emerge in a bubble where stars glow blue instead of yellow, or where time ticks twice as fast? Would you find galaxies shaped like spirals, cubes, or something stranger, patterns you don't even have words for? The thought makes you chuckle softly. Somewhere maybe there's a universe where bedtime stories are written in geometric fractals, and your counterpart is puzzling them out just as you puzzle over mine. The foam metaphor works well here. If you've ever poured soda into a glass, you've seen the bubbles rise, swell and press against each other. Each bubble has its own interior sealed off from the rest. Our bubble, with its galaxies and dark matter and humming background radiation, is just one fizzing sphere in an infinite glass. And just like soda bubbles, sometimes they collide. In fact, some cosmologists speculate that scars on our cosmic microwave background, the faint cold and hot spots, might be bruises from collisions with other universes. Imagine two bubbles pressing together, their skins warping where they touch. That warp might leave faint imprints in our sky, like fingerprints smudged across the baby picture of the cosmos. Observers have combed through CMB maps looking for these signatures. Some claim they see hints, others dismiss them as statistical noise. Historians still argue whether those strange anomalies are real evidence of a cosmic bump or just artifacts of our instruments. You linger on the thought, letting it swirl in your mind. If our bubble really did brush against another, what would that mean? Would physics leak across the boundary? Would their laws infect ours like perfume drifting from one room into another? Or would the two universes simply rebound, drifting apart, leaving nothing but faint ripples in the cosmic fabric? It feels like standing on the shore, imagining waves crashing from a storm beyond the horizon. You can't see it, but you know something vast is moving out there. Here's a quirky tidbit to keep you smiling. In one playful version of bubble theory, some universes could have physical laws so strange they'd be unrecognizable. Gravity might push instead of pull. Atoms might never form, leaving only endless fog. Or perhaps, in one particularly cheeky bubble, every electron insists on being just slightly bigger, making its physics ever so subtly wrong. You picture such a universe trying to form stars, failing miserably, and sulking in the corner of eternity. Not every bubble can be a winner after all. Meanwhile, you recline in your own bubble, appreciating its quirks. Sure, your universe may throw black holes and dark energy at you, but at least it allows chemistry, life, and the occasional cup of coffee. In the grand lottery of inflationary foam, you lucked out. Somewhere in another bubble, an alien version of you might be floating without sleep or dreams, simply buzzing with particle static. You smile at the contrast. This bubble may be a cage, but it's a cozy one. The fan in your room hums again, and for a moment, you imagine it's the bubbling sound of universes colliding gently in the distance. Each vibration, each pulse, could be the faint song of bubbles pressing, separating, pressing again. You're reminded that while humans crave singularity, one universe, one story, the cosmos seems more comfortable with plurality. Why have one when you could have many? Historians still argue whether eternal inflation makes the universe too big, too strange to be useful. Some complain that if there are infinite bubbles, then anything you can imagine must exist somewhere, which makes the theory impossible to test. Others counter that this infinity doesn't cheapen our universe, it enriches it. We're not just an accident, we're part of a grand cosmic froth, one bubble in a vast fizzing sea. You tilt your head and imagine drifting along the surface, sliding across bubbles like a soap film surfer. Each one shines in different colours, some glowing gold, others deep purple, some invisible to your eyes. You glide past them, wondering what lies inside. Do they hum with their own background hiss? Do they stretch with their own horizons? Or are some short-lived, popping before they can form stars, like bubbles that burst before you can admire their shine? The thought lulls you, paradoxically. Instead of making your world feel small, the idea of countless universes makes you feel less lonely. Your bubble isn't isolated. It's part of a community, even if you'll never knock on your neighbour's door. You're surrounded, embraced by an unseen froth of existence. And that thought, whimsical as it is, rocks you like a lullaby. So you stay here at the edge, gazing at the shimmering surface of your bubble. You don't push through, you don't need to. Just knowing the foam might exist is enough. Beyond your horizon, universes may press together, collide, sparkle, or vanish. Some may hold life, others only silence. And you float quietly in your bubble, carried gently by the endless froth of inflation's sea. You've been rocking gently in your bubble, admiring its shimmer against the foam of eternity, when another thought drifts in, sly and irresistible. What if your bubble isn't floating alone in empty space at all? What if it's resting on something larger, something vast, hidden, and dimensionals beyond your imagination? This is the strange, almost psychedelic suggestions of brane world theory. The name comes from membrane, though physicists like to shorten it to just brane. Imagine a vast cosmic sheet, thin but flexible, stretching across dimensions you cannot see. Your entire universe, galaxies, stars, black holes, bedtime musings, is painted across that sheet like dust motes glued to a trampoline. Everything you know exists on this brane, suspended in a higher dimensional space called the bulk. The bulk is the backstage of reality, a place where other branes may also float, parallel to yours, like sheets of paper stacked in a cosmic binder. You hover there in your drifting dream, imagining universes layered side by side, separated by dimensions as invisible to you as radio waves are to your eyes. Our cosmos could be a two-dimensional slice embedded in some vast multi-dimensional loaf. If you could step sideways, not forward, not backward, but sideways into a new dimension, you might brush against another brane, another universe pressed close but forever hidden. Historians still argue whether brane theory belongs to the solid halls of physics or the more speculative lounges of imagination. It grew out of string theory, which itself is controversial. In string theory, the tiniest bits of matter aren't points but vibrating strings, and those strings need extra dimensions, 10, 11, maybe more, to make sense mathematically. Most of those dimensions are curled up invisible, but some, like the ones that might host branes, could stretch infinitely, holding entire universes within them. The idea is equal parts rigorous and poetic, which is probably why it sticks. You try to picture it, our brane like a glowing film, galaxies twinkling across it. Above and below, or perhaps elsewhere in a direction your brain isn't wired to grasp, other branes drift. Some may be lifeless, barren sheets. Others might be as rich and chaotic as ours, with their own versions of stars, physics, even living beings wondering what lies beyond their own horizons. You almost laugh, realizing you've just imagined brane-based creatures tucked into bed, listening to someone whispering about universes on other branes. Cosmic déjà vu. There's a strange comfort in the trampoline analogy. Picture kids bouncing on a trampoline, their weight bending the surface. According to some versions of brane theory, gravity might leak between branes, tugging them toward one another, or creating subtle effects we can measure. If you've ever wondered why gravity feels weaker compared to other forces, why a fridge magnet can overpower the entire Earth's pull on a paperclip, brane worlds offer a cheeky answer. Maybe gravity's strength is diluted because it seeps into higher dimensions, spreading out like perfume through cracks in a floorboard. Here's a quirky tidbit. In some brane cosmologies, the Big Bang itself might not have been a singular beginning but a collision. Two branes drifting in the bulk could have smashed together, releasing energy that bloomed into a universe. You imagine it like cymbals clashing in a silent symphony, two invisible sheets meeting, sparking light, birthing stars, and leaving you billions of years later to marvel at bedtime. If true, then our existence is the aftershock of a cosmic fender bender. Historians still argue whether there's evidence for brane collisions. Some point to odd features in the cosmic microwave background, those mysterious cold spots and alignments as potential bruises from ancient impacts. Others caution that the data is messy, easily explained by the chance. Still, the thought lingers. Maybe our universe carries scars from its brain-to-brain childhood fights, faint fingerprints from dimensions we'll never see. You recline deeper, letting your imagination slip into those higher spaces. It's hard to picture 11 dimensions when you're used to 3, but your mind does its best. Maybe they feel like colours you can't perceive or directions you can't walk. You reach sideways and the air shivers with possibility. For a moment, you almost sense another brane just out of reach, brushing faintly against yours. Then it fades, leaving only the familiar hush of your own cosmos. And still, the fan in your room hums, grounding you in the simplest of dimensions, forward and back, side to side, up and down. It's enough for daily life, enough to find your pillow, enough to close your eyes, but tonight you're content to let your mind stretch beyond, wandering where even the most ambitious telescopes can't follow. Some fringe thinkers take brane theory further, suggesting that entire universes might occasionally touch, bleed into one another, or even merge. Science fiction loves to run with this. Parallel worlds brushing against ours, seeping characters, histories, or physics through the cracks. In one story, you'd find yourself stepping into a brane where history ran differently, where empires never fell or stars never formed. In another, you'd step into silence, greeted by endless void. The possibilities make you grin and shiver at the same time, but the deeper truth is simpler, gentler. You don't need to leap brains tonight. It's enough to know that theories like this exist, that physicists sit awake scribbling equations, trying to picture universes beyond universes. You're part of a species that refuses to be satisfied with one world, one reality. You reach for layers, for foams, for brains stacked in invisible binders. That hunger, even more than the theories themselves, is what makes you special. So you settle into the softness of your own brain. You feel it stretch beneath you like a hammock, holding you steady in the bulk. Maybe other brains drift nearby. Maybe collisions loom in the distant future. Maybe gravity leaks and whispers secrets across dimensions. Or maybe it's all just imagination. Bubbles stacked on bubbles, stories layered on stories. But for now, as sleep presses gently against your eyelids, it doesn't matter. You're safe on your brain, drifting in the dark sea of the bulk to rocked by theories as soothing as lullabies. You've been lounging on your brain, rocked gently like a hammock, stretched across unseen dimensions, when another thought flickers into your mind, one so strange it feels less like science and more like a trick your half-dreaming brain might play on itself. What if somewhere out there's a universe that mirrors ours, not just in its layout of galaxies, but in something more fundamental? A place where time doesn't march forward like a stern schoolteacher tapping its watch, but instead drifts backward, unwinding, retracing, reversing every tick of the clock. The idea of a mirror's universe isn't just comic book fodder. In physics, symmetry is sacred. Many of the universe's laws look the same whether you flip space, reverse charge, or rewind time. Yet there are little exceptions, tiny asymmetries that make our world what it is. Some physicists speculate that those quirks might be balanced by a counterpart cosmos, a reflection across some invisible divide. Like two sides of a coin, our universe heads, theirs tails. You picture it now, galaxies unwinding into primordial fog, stars collapsing not into black holes, but blossoming outward into gas. People waking up by climbing into bed, sipping coffee into full mugs, living their lives in reverse. To them, it wouldn't feel wrong. They wouldn't be rewinding, they'd be experiencing their own version of forward. To you, it looks like a film played backwards. To them, you'd look absurdly broken. Historians still argue whether time's arrow, our sense that the future is different from the past, is inevitable, or an illusion born from entropy. Entropy, the measure of disorder, always increases, which is why eggs don't unscramble and spilled milk doesn't leap back into the glass. But what if another universe's entropy arrow points the other way? What if their milk unspills, their chaos untangles, their disorder declines? The debates echo in dusty lecture halls, unresolved, fascinating, and oddly cozy when you think about it in the dark. You grin at the quirks of it. In your mirror's universe, you'd first hand back your diploma, then spend years unlearning facts until you were back in kindergarten drawing stick figures. You'd slip smaller clothes on year by year, until at last, you'd be cradled in a womb before vanishing into non-existence. Grim? Maybe. But from the mirror side's perspective, that's just life's natural unfolding. They'd probably find your timeline equally disturbing. Wait, they'd say. You start small and helpless, grow increasingly tired and wrinkled, and then die. That's so inefficient. Here's a quirky tidbit. In 2018, researchers studying neutrinos, those ghost-like particles that stream through you by the trillions every second, detected anomalies that some whispered could hint at a mirror universe. Their experiment in Antarctica involved particles behaving as if they were violating expected patterns, almost as if they were slipping into an inverted realm. Mainstream physicists quickly raised eyebrows and cautioned that the data was far from conclusive. But the whispers stuck, because who doesn't love the idea that somewhere under your feet, through a sheet of ice, another cosmos might be brushing against yours? As you float, you let your mind play with the image of mirrors upon mirrors. Your universe expands forward, theirs contracts backward. Maybe the Big Bang wasn't a beginning but a midpoint, a cosmic junction where two arrows of time burst out in opposite directions. From their perspective, we are the backward universe. Somewhere, perhaps, another version of you is drifting into sleep as well, listening to a mirrored narrator explain your strange forward-flowing cosmos. It's enough to make you chuckle softly in the quiet. Historians still argue whether such a mirrored cosmos is testable. Some say no. If we're forever sealed from it, then it's philosophy, not physics. Others suggest subtle signatures might exist, patterns in the cosmic microwave background, odd behaviours in fundamental particles, whispers at the edges of equations. The jury remains out, rocking gently between skepticism and wonder. You, meanwhile, are content to let the question dangle like a dream catcher above your bed. You stretch your arms in the dark, imagining the invisible surface between universes as a polished black mirror. You lean closer. Your reflection doesn't mimic you, it moves opposite, raising the other hand, blinking at the wrong time, smiling when you frown. The effect is eerie but soothing, like a reminder that balance lurks in hidden places. For every twist, a counter-twist. For every flow, a counterflow. The fan in your room hums again. But now you imagine it reversed, blades unwinding the air instead of stirring it. The hum doesn't fade, it sharpens into a backward lull, as though you're listening to a record spun the wrong way. It should sound wrong, but instead it feels hypnotic, as if your brain secretly recognizes the reversed melody. You breathe in, slow and deep, and for a fleeting second you can almost feel time loosen its grip, allowing you to drift both forward and backward at once. There's a gentle humour in the thought of mirror beings. Somewhere out there, maybe a counterpart of you is right now frowning at the thought of forward-flowing time, scribbling a bedtime story about universes where entropy increases, where people age, where everything inevitably falls apart. They shake their head, baffled, and then yawn backward into alertness. Two sleepers mirrored across eternity, chuckling at one another without ever meeting. And isn't that the charm of it all? You don't need to cross the mirror tonight. You don't need to prove it exists, the possibility eye is enough. A shimmering reflection beyond your horizon, time ticking in reverse, entropy unwinding like a spool of thread pulled neatly back onto its reel. Whether or not it's real, the idea itself rocks you into calm curiosity. You close your eyes and the mirror darkens. Somewhere perhaps, another universe wakes as you drift. Its people stepping backward into their mornings as you slide gently into night. Both universes hum together, reflection forever apart yet forever entwined. And you're content to let their backward lullaby echo faintly in your dreams. You let the mirror darken and fade, its backward whispers softening into silence when another possibility sneaks in, sly as a cat curling onto your lap. What if the universe doesn't just exist in one continuous sweep, forward or backward, but instead splinters, branching like an endless tree every time a choice is made, every time a particle wavers between possibilities? This is the strange promise of the many worlds interpretation of quantum mechanics. Not one universe, not even two mirrored ones, but countless blooming endlessly with every flicker of probability. The thought settles over you like mist. Imagine holding a coin, you flip it. In your world it lands heads, but somewhere in a parallel branch it lands tails. Both outcomes are real, both universes carry on, both versions of you breathe, blink and move forward. Every time you make a choice, tea or coffee, socks or no socks, another branch sprouts. The tree of existence stretches into infinity, so tangled and vast that even eternity couldn't map it. Historians still argue whether Hugh Everett, who first proposed the many worlds idea in the 1950s, was a misunderstood genius or a man handing philosophy a toy it wasn't ready for. His contemporaries scoffed. Niels Bohr and other champions of the Copenhagen interpretation insisted that quantum possibilities collapse into a single outcome when observed. Everett disagreed. Nothing collapses, nothing vanishes. Instead, every possibility happens, and the universe splits quietly behind the curtain. He presented his thesis, was largely ignored, and retreated from academia. Only decades later did physicists revisit his ideas, realizing how eerily elegant they could be. You imagine Everett now, a ghost drifting among his own infinite branches, watching versions of himself live out every choice he ever made. Somewhere, one Everett stayed in academia and won a Nobel Prize. Somewhere else, one gave up physics entirely and opened a bakery. All of them are real, all carrying on, none aware of the others. You smile at the absurdity and the quiet melancholy of it. The tree grows in your imagination. Branches split, then split again, each sprouting leaves of possibility. A version of you chose to stop scrolling earlier tonight and never reached this story. Another chose popcorn instead of tea. Another decided to sleep 2 hours ago. And here in this branch, you're floating in a universe where you stayed, listening. following me past horizon after horizon. The branches multiply, twining into a forest no eye could ever survey. Here's a quirky tidbit. The many worlds idea has a funny consequence when paired with Schrödinger's cat, the famous thought experiment. In one branch, the cat lives. In another, it dies. In a third, maybe the cat escapes the box entirely and files a complaint about the whole setup. Jokes aside, Everett's interpretation sidesteps the problem. The cat doesn't exist in a fuzzy blur of alive and dead until you look. Both outcomes are real, each in its own universe. The box just hides the branching from your view. Historians still argue whether this makes the theory too bloated. Do we really need infinite universes to explain why your toaster either works or doesn't in the morning? Critics call it extravagant, like buying the whole restaurant just to taste a single meal. Yet supporters counter that it's elegant precisely because it removes the messiness of collapse. Physics carries on, probabilities unfold, and the universe handles all options with no arbitrary cutoffs. The price, of course, is infinity. You lean back, half amused, half drowsy. Infinity is a heavy word, but here in the dark it feels light, like a cloud drifting overhead. You picture versions of yourself wandering through countless branches, one winning the lottery, one missing the bar, one deciding to move to a different city, one never discovering this sleepy science channel. You'll never meet them, never peek into their lives, but their existence makes your own feel both trivial and strangely precious. Out of all the branches, this is the one you've landed in tonight, and somehow that feels like a small miracle. The fan in your room hums again, steady and grounding, and you imagine it as a metronome marking the rhythm of branching universes. Tick, another decision splits. Tick, another branch grows. Tick, another you stretches and yawns, curling into sleep in a different reality. The sound becomes soothing, a lullaby of infinite possibilities. And then a funny thought strikes you. If universes branch endlessly, does that mean somewhere there's a version of you who never existed at all? A branch where your great-grandparents never met, or where the Earth itself never formed? The tree grows not only into variations of you, but into vast forests where you're absent entirely. That should feel lonely, but it doesn't. It feels liberating. You're not the centre of the story. You're just one of the leaves, glowing briefly on an endless tree. Another smile tugs at your lips as you recall a pop culture quirk. In comic books and movies, multiverses often play with this exact idea. Alternate versions of characters meeting, clashing, or teaming up is dramatic, loud, and messy. But in real physics, if many worlds is true, the branches remain forever sealed. No crossovers, no multiverse conventions, just quiet, separate tapestries unwinding on their own. That solitude makes it strangely more poetic. No drama, just endless unfolding. Historians still argue whether quantum branching cheapens choice. If every decision spawns a branch where you chose differently, does that mean free will is an illusion? Some philosophers sigh, some shrug, some grin and order another drink. But here, in your drifting calm, it doesn't feel cheap at all. It feels abundant. Instead of one brittle thread, existence is a tapestry woven thick with possibilities. Your branch matters not because it's unique, but because it's yours. You close your eyes briefly and imagine the branches glowing around you, a forest of light stretching into eternity. Each glow is a universe, quiet and complete, humming with its own possibilities. You wander between them, not choosing, not intruding, just admiring. The forest rocks you like a cradle, each branch a lullaby, each glow a whisper. You don't need to explore them. It's enough to know they're there, infinite, uncountable, spreading forever into the night. The forest of quantum branches fades around you, glowing universes dimming into silence, and once again you find yourself floating in your own familiar bubble. You're just beginning to feel settled when another ripple tugs at your mind. Gentle at first, then strangely insistent. It feels like being caught in a current, like the entire cluster of galaxies you've been admiring is being nudged in one direction, drifting together as if something invisible has them on a leash. This is the puzzle astronomers call dark flow. You imagine it now. Entire galaxy clusters, thousands of trillions of suns sliding quietly across the universe, not just from ordinary expansion, but towards something. Their motion isn't random nor fully explained by the known distribution of matter. It's as if a gravitational hand beyond the horizon is reaching in, pulling. The mystery first surfaced in the late 2000s when researchers using NASA's Wilkinson Microwave Anisotropy probe noticed a strange alignment in the motion of distant clusters. They weren't just drifting outward with the rest of cosmic expansion, they seemed to share a peculiar directional flow stretching toward a patch of sky, like moths to a lamp. The speed, up to 1,000 kilometers per second. That's fast enough to cross from Earth to the Moon in under 7 minutes. Not bad for entire galaxies. Historians still argue whether this dark flow is even real. Some teams swear the data shows a clear pattern, while others insist it's noise, statistical illusion, or simply measurement error. The debate has grown heated at times, with papers volleyed back and forth like cosmic tennis balls. But for your wandering mind, the uncertainty only makes it better. Nothing sparks sleepier wonder than an unsolved puzzle tugging quietly at the edges of understanding. What could cause it? One possibility is that immense structures beyond our observable horizon are exerting their gravitational pull, tugging galaxies toward them like an unseen magnet. If so, it means there are massive concentrations of matter out there, superclusters so large they dwarf imagination, that we will never see directly. They lie forever hidden beyond the cosmic horizon, and yet their influence reaches us all the same. You picture them now, titanic clumps of galaxies strung together in webs thicker and grander than anything you've already seen. They lurk in the dark, unseen, like sea monsters beneath a foggy ocean. Their pull is gentle but insistent, tugging your bubble from the outside. You can't spot their glow, but you can feel their fingerprints in the flow. Here's a quirky tidbit. Some have speculated that dark flow could hint at something even stranger than unseen clusters. Maybe it's the gravitational effect of entire other universes brushing against ours. Imagine two bubbles pressed so close that their gravity leaks across, nudging galaxies like a finger-tapping glass from the other side. It's speculative, fringe, and controversial, but also irresistibly cinematic. Somewhere out there, another cosmos might be flexing its weight, and your galaxies are responding like ships tugged by a hidden tide. The fan in your room hums, and for a moment you imagine it's the sound of those galaxies sliding, a steady whisper of motion across the void. You breathe in, and the thought soothes rather than unsettles. After all, even your own planet drifts through space at dizzying speeds, circling the sun, wheeling around the galaxy, carried along by currents you never feel. Why shouldn't whole clusters drift too? Historians still argue whether dark flow will fade away as instruments improve, a ghost of bad data rather than a true discovery. Some say it's already been explained away, while others point to lingering hints that won't quite disappear. The truth remains unsettled, tugging at both galaxies and minds alike. You smile at the thought of it, an entire mystery sparked not by what we see, but by how things move. It's like noticing a friend glancing repeatedly at the same corner of the room. You don't know what's there, but their gaze tells you something is. The galaxies, in their slow, steady slide, are glancing. And you, patient observer, are left to wonder what invisible presence commands their attention. It makes you think of the old navigators, charting ocean currents long before they understood the winds or tides that drove them. They watched ships drift in directions they couldn't predict, chalking it up to hidden forces of the sea. In a way, cosmologists are doing the same, watching galaxies drift, scratching their heads, suspecting a tide beyond the map. You stretch in your drifting space, feeling the tug yourself now. It's subtle, almost imagined, like being pulled toward the edge of sleep. You picture yourself as one more speck carried in the dark flow, sliding across space-time in harmony with galaxies larger than anything you can fathom. The pull doesn't frighten you. It soothes, like a lullaby current rocking you deeper. Some dreamers whisper that dark flow might one day give us clues about the multiverse. If it really is the tug of another bubble brushing ours, then it's a rare, indirect sign of universes beyond. Others wave this off as fantasy, but even if it's just giant unseen structures, cosmic continents lying forever out of view, that's still a marvel. It means the universe extends beyond imagination, rich with wonders hidden from sight yet still shaping your reality. And isn't that a perfect metaphor for drifting to sleep? So much lies beyond your conscious horizon, unseen and unknowable, yet it still pulls at you, still shapes your dreams. You don't need to see the other side to feel its influence. The galaxies slide, the current whispers, and you, rocked gently in the dark, are carried along. The tug of the dark flow hasn't even left your imagination when another pull makes itself known, this one closer, stranger and more personal. It's not the whole observable universe sliding in one mysterious direction. It's our galaxy, along with its neighbours, being drawn towards something immense, hidden behind curtains of cosmic dust. Astronomers call it the Great Attractor. And the name alone makes you smirk. It sounds less like a scientific concept and more like a superhero's nemesis. Still, the mystery it represents is very real. And tonight you can feel it pressing against you like gravity itself. You imagine the Milky Way now, not standing still, but gliding through space at hundreds of kilometers per second. Alongside us, thousands of galaxies drift, all pulled together toward the same patch of sky in the constellation Centaurus. It isn't just expansion carrying us, something massive is tugging from beyond the veil, hidden in a region of the sky astronomers once called the Zone of Avoidance, a place so cluttered with the thick band of our own Milky Way that it's nearly impossible to peer through. Dust, stars and gas obscure the view, leaving us guessing at the monster behind the curtain. Historians still argue whether the Great Attractor should even be considered a thing, or merely the combined gravity of many superclusters in one direction. Early on, when scientists first noticed the motion of our galaxy relative to the cosmic background radiation, the anomaly seemed mysterious enough to demand a single culprit. But as maps improve, the picture grew fuzzier, and the debate hasn't entirely faded. It's like watching shadows flicker on a wall and arguing whether you're looking at one giant figure or a crowd of smaller ones huddled together. You drift deeper, picturing yourself at the bow of a ship pulled steadily toward an unseen island. The starlight around you tilts slightly, as though leaning into the motion. You know the island's out there, massive, irresistible, but for now it's just mist and rumour. Astronomers estimate the Great Attractor's pull comes from a region with tens of thousands of galaxies spread across hundreds of millions of light years. That's not an island. That's a continent, a cosmic landmass so heavy it bends the trajectories of everything nearby. Here's a quirky tidbit. The discovery of the Great Attractor in the 1970s and 80s led some to speculate wildly that maybe it was a single supermassive object, something exotic, like a black hole on steroids. Of course, that doesn't hold up to scrutiny. What we're really seeing is the combined gravity of clusters and filaments of matter, mostly dark matter, forming part of what's now called the Laniakea supercluster. Laniakea, by the way, is a Hawaiian word meaning immense heaven, a name chosen to capture the beauty of our galaxy's true home in this grand cosmic web. Not bad for a mailing address. You can't help but laugh quietly at the drama of it. The Great Attractor sounds terrifying, like some cosmic vacuum waiting to swallow us. In reality, we're just part of a vast network of galaxies, all bound together by gravity's gentle but inexorable hand. It isn't pulling us into doom, it's guiding us, like a parent tugging a child across a busy street. Still, there's a strange comfort in imagining the hidden mass as something alive waiting beyond the dust. You lean into the feeling of being drawn, letting it rock you like a current. Your galaxy, your planet, your pillow, all sliding toward an unseen anchor, all part of a collective drift you can't escape. It doesn't feel frightening. It feels unifying. You're part of a migration larger than history, larger than life itself. Historians still argue whether we'll ever map the Great Attractor in full detail. Infrared telescopes and radio surveys have peeled back some of the dust, revealing tangled structures like the Norma cluster and the Shapley concentration, regions swollen with thousands of galaxies. Yet even now the Zone of Avoidance hides much, as though the cosmos enjoys keeping one last card tucked up its sleeve. Maybe we'll never see it all. Maybe that's the point. The fan in your room hums steadily, and you imagine it as the Great Attractor's call, low and unwavering. It isn't urgent, it isn't loud, it's simply there, shaping everything without demanding recognition. You breathe in and out, syncing with that hum, letting yourself be carried along with the galaxies. You don't fight it, you don't resist, you let the current pull. Another thought tickles you. What if the Great Attractor isn't unique at all? What if the universe is littered with such giants, gravitational hubs, each gathering galaxies like bees around a hive? Then our motion is just one of countless drifts, each bubble sliding toward its local anchor, all tied together in a web too vast to fathom. And indeed, that's what modern cosmology suggests. Clusters, superclusters, filaments, voids, a cosmic sponge where matter clumps and hollows stretch like the pores of bread. The Great Attractor is just one fat knot in the weave, but tonight you don't need the whole weave. one knot is enough. You picture it glowing faintly beyond the dust, invisible but undeniable, calling quietly across millions of light years. Its pull threads through you now, as gentle as a lullaby tugging you toward rest. You don't need to see the great attractor. You only need to feel its inevitability, the way galaxies lean into its gravity, the way even silence tilts in its direction. And so you drift, not fighting the current, not worrying where it leads. The great attractor, hidden though it is, reminds you that sometimes it's okay not to know. Sometimes being pulled, carried, guided by forces beyond your understanding is enough. The galaxies follow, you follow, sleep follows, the pull of the great attractor fades into the background. A steady hum you no longer resist, when another oddity surfaces in your thoughts, this one not a tug but a chill. You remember the cosmic microwave background, that faint hiss of afterglow painting the sky in nearly perfect uniformity. Almost perfect. Because tucked in that map is a blemish, a patch of space colder than the rest, as if the universe itself caught a bruise. Astronomers call it the cosmic cold spot, and tonight it lingers in your imagination like a draft sneaking under the blanket. You picture it as a faint smudge in the baby picture of the universe. Everywhere else, the background glows at 2.7 Kelvin, give or take tiny ripples. But in this one region, hundreds of millions of light years across, the temperature dips noticeably lower. It isn't just a blip of bad data. Satellites like DomeMap and Planck have confirmed its reality. Something about this patch of sky is undeniably colder, quieter, emptier, and nobody fully knows why. Historians still argue whether the cold spot is simply a statistical fluke, a random ripple in the early universe stretched into something larger by inflation. Others think it might be caused by a massive void, a region of space with fewer galaxies than average. Light travelling through such an emptiness could lose energy, making the patch look colder when it reaches us. It's like shouting across a canyon and hearing your echo come back thin and hollow. But some whisper stranger possibilities. What if the cold spot is the scar of a cosmic collision? Imagine our bubble universe brushing against another during inflation, the impact leaving a faint bruise on our sky. The cold spot could be the lingering fingerprint of another cosmos, pressed against ours before drifting away into the bulk. It's speculative, controversial, but deliciously unsettling. Evidence, perhaps, that we're not alone even on the scale of universes. You drift closer in your mind, hovering at the edge of this chill region. The stars thin, galaxies retreat. The darkness deepens into something colder than silence. It isn't frightening though, so it feels oddly peaceful, like stepping into a quiet forest after a snowfall. The hush wraps around you, stilling every thought until you're just a breath suspended in frozen eternity. Here's a quirky tidbit. The cold spot became so famous that some astronomers jokingly called it the cosmic bruise, as if our universe got into a bar fight and never quite healed. One even suggested, tongue firmly in cheek, that it could be the shadow of a giant structure shaped like a donut. Theories range from playful to profound, each one adding another layer of charm to this patch of mystery sky. Historians still argue whether voids large enough to cause the cold spot even exist. Surveys of galaxies in that direction have found some emptiness, but not nearly enough to explain the dip in temperature. It's like checking under the bed for a draft and finding nothing, yet still feeling the chill. The gap between data and explanation lingers, teasing both scientists and dreamers. You recline into the chill now, letting it seep into your imagination. The fan in your room hums softly, and you fancy it's carrying the cold spot's breeze across the billions of years. The air feels cooler on your skin, though you know it's just suggestion. The body responds anyway, curling slightly under the blanket, cozy against the phantom frost. It strikes you how human this all is. From Earth, a tiny speck orbiting an average star, we notice a subtle dip in temperature across the sky and immediately spin stories. A void, a bruise, a collision, a shadow of another universe. The universe hands us the faintest clue, and we can't help but build castles of speculation on it. Maybe that's the point. Maybe the cold spot isn't meant to be solved quickly, but to remind us how eager we are to weave meaning from whispers. And then another thought settles, slow and calming. Even if the cold spot is nothing more than chance, it's still beautiful. A random quirk in the universe's baby picture is no less wondrous than a cosmic bruise. Flukes are part of nature's charm. The freckles on your skin, the knots in a tree, the craters on the moon, each is a random imperfection that makes the whole more interesting. Why shouldn't the universe wear freckles too? The galaxies beyond the cold spot shimmer faintly, blurred by the dimness, as though seen through frosted glass. You don't need to solve their mystery tonight. You only need to rest in the chill, letting it slow your breath, letting the hush deepen. The cold spot, whatever it is, becomes less a puzzle and more a lullaby. A patch of quiet in the endless hum, a pause in the music of creation. So you let the cold settle over you, not as menace, but as comfort. Beyond the galaxies, beyond the voids, beyond even the bruises of colliding universes, the cold spot waits, patient and eternal. You float in its shadow, cozy in the quiet, feeling sleep creep closer, like frost painting the edges of a window pane. And you smile, knowing that even the universe has its cool, quiet places. The hush of the cosmic cold spot lingers in your thoughts like frost on glass. But soon another possibility stirs, this one less chilly and more mischievous. What if the fabric of the universe isn't smooth at all, but restless and twitching like a quilt sewn too quickly? What if instead of remaining whole, it sometimes punches holes through itself, tunneling between realities like a worm bored of staying in one apple? This is the strange idea of quantum tunneling between universes. You picture the cosmos not as a bubble resting quietly in foam, but as a restless field of energy, seething even in its calmest state. Quantum mechanics insists that even nothing isn't truly nothing. The vacuum hums with fluctuations, tiny blips of energy sparking into being, then vanishing just as quickly. Usually they cancel out harmless flickers, but sometimes perhaps they add up, punching through the fabric and birthing something new, a whole universe maybe, tunneling its way into existence out of quantum restlessness. Historians still argue whether this false vacuum decay scenario is a serious threat or just an elegant curiosity. The math says that if our universe is trapped in a metastable state, not the lowest possible energy configuration, then a quantum fluctuation could someday trigger it to collapse into a lower energy vacuum. The result? A bubble of new physics expanding at nearly the speed of light, rewriting the laws of reality as it consumes everything. Cheerful bedtime thought, right? Don't worry, the timescales involved are so vast that you'll have died, reincarnated, and written 1,000 forgotten grocery lists before it matters. Still, the possibility tickles your imagination. You picture little bubbles of new universes tunneling into being, sprouting like mushrooms in a damp forest. Each one inflates, grows, and becomes its own cosmos, separate and unreachable. Maybe your own universe was born this way, a quantum tunnel opening into possibility, spilling light, time, and matter into the void. Here's a quirky tidbit. In 1982, physicist Sidney Coleman described vacuum decay with such dark humour that his paper remains infamous. He called it the fate of the false vacuum, and noted with unnerving cheer that if such an event occurred, there would be no survivors to worry about it. It's the kind of sentence that makes you laugh nervously, then shrug. After all, if the universe can blink out without warning, worrying about it is like fretting over whether your dream pillow is filled with feathers or cosmic dust. You drift further, imagining what tunneling would feel like. One moment, everything's ordinary. The hum of the fan in your room, the steady pull of gravity, the taste of tea still lingering on your tongue. The next, reality itself reshuffles. Constants shift, atoms fall apart, stars dissolve into new physics you can't recognize. To the new universe, it's simply the dawn of creation. To the old, it's silence. But here in this dreamlike float, it feels less like doom and more like transformation. A caterpillar slipping into chrysalis, only this chrysalis contains entire galaxies. Historians still argue whether tunneling can ever be observed or tested. Some suggest we might find clues in the cosmic background radiation, scars of ancient tunnels, faint imprints of neighbouring vacuums brushing against ours. Others dismiss this as wishful thinking. If universes tunnel, they say, they remain sealed off, unreachable, their evidence erased the moment they form. The debate meanders on, equal parts physics and philosophy, like so many of the questions that rock you towards sleep. You stretch your arms in the dark as though feeling for holes in the air. Nothing tears, nothing gives, but in your mind, tiny pinpricks open and close around you. You imagine peeking through one and glimpsing a different reality. Skies glowing green, stars humming in chords instead of light, beings made of patterns you can't name. The holes wink shut before you can step through, but the glimpse is enough to make you smile. The fan hums on and you fancy it's the sound of universes tunneling, faint breezes slipping through holes you can't see. Each vibration is another reality sprouting, expanding, vanishing beyond your reach. The thought is oddly soothing. The universe isn't static. It's alive, restless, playful. Even its fabric gets bored and makes something new. Another funny thought. If universes tunnel, do they leave drafts? Does some tiny shiver of their birth ripple through ours like neighbours moving furniture upstairs? Perhaps the cold spot you visited earlier was one such draft, a bruise left by tunnelling. Perhaps dark flow itself is the tug of a nearby newborn cosmos flexing its gravitational muscles. No proof, of course, but your drowsy imagination loves the connections, and so you float, content not to solve the puzzle. Whether tunnelling is real or not, it gives you an image to hold as you sink deeper. Universes sprouting like mushrooms, tunnelling through quantum soil, growing into realities too vast to count. Your own existence, perhaps, just one among countless blooms. That thought doesn't shrink you. It cradles you. It means the cosmos is fertile, generous, endlessly creative. The holes wink open, wink shut. Your breath slows with them, steady, rhythmic. You don't need to crawl through to know they're there. You only need to imagine the possibility that beyond your bubble, beyond your brain, beyond your cold spots and attractors, new universes might be tunneling into being right now, blooming quietly in the quantum dark. The thought of universes tunneling like mushrooms sprouting from damp soil lingers in your mind, but it doesn't stay alone for long. Soon, another image arrives, bigger, stranger, louder. Not just one or two bubbles, not even an occasional tunnel here or there, but a multiverse. A whole zoo of universes, each different, each bizarre, each following its own laws of physics the way exotic animals follow their instincts. You find yourself wandering through it now, a cosmic zookeeper with no keys, only wide eyes. Imagine a corridor stretching beyond sight, lined with doors. Behind each door lies a universe, but no two are alike. You open one. Inside, gravity is 10 times stronger. Stars live only a few million years before collapsing, planets are crushed into barren wastelands, and life has no foothold. You close the door gently. Another door creaks open. Here, gravity is so weak that galaxies never form. Matter drifts aimlessly. A fog of particles with nowhere to gather. You sigh and step back. So many doors, so many failures. And yet you stumble upon another. Inside, the laws look just right. Gravity, chemistry, the balance of forces, all tuned in a way that allows stars, planets, oceans, and eventually beings like you to wonder about it all. This is the anthropic principle whispered by cosmologists and philosophers alike. Out of all possible universes, you find yourself in one that permits your existence, because where else could you be? Historians still argue whether invoking the anthropic principle is a profound truth or a cosmic cop-out. Some say it explains nothing, like shrugging and declaring, well, we're here because we're here. Others argue it's the only logical conclusion in a multiverse. Countless universes exist, but only a sliver can host observers. You're simply in one of the rare pens in the zoo where creatures like you can thrive. You wander further through the zoo, past pens filled with oddities. One universe glows with 3 spatial dimensions like yours. Another has 4 where gravity knots itself in ways no planet can orbit. A third has only 2, flat and strange, where beings, if any exist, can never cross paths without colliding. It's a gallery of physics experiments, most doomed, some unthinkably alien, all real if the multiverse is true. Here's a quirky tidbit. The physicist Max Tegmark once categorized the multiverse into 4 levels, ranging from simple regions beyond our horizon to universes with entirely different mathematics. His level 4 multiverse is the strangest. Every consistent mathematical structure exists as its own universe. If the math works, it's real somewhere. That means universes of cubes, universes of spirals, universes shaped like fractal snowflakes repeating forever. It's less a zoo and more an infinite library, every equation given a stage to perform. Historians still argue whether this stretches science beyond reason. Some critics say a zoo of universes is untestable, an endless parade of cages will never unlock. Others defend it, pointing out that inflation, string theory, and quantum branching all naturally lead to multiverse scenarios. If so many roads point to the zoo, maybe the zoo is the destination, whether or not you ever buy a ticket. You pause at one pen in your wandering, peering into a universe where the speed of light is slower, so slow that stars never burn bright but only smoulder. It's dim, quiet, melancholy. You step away. Another pen shows a universe where light doesn't exist at all. No photons, no glow, just matter, stumbling blindly in the dark. The creatures there, if any, must navigate by something other than sight. You wonder if they envy you, or if they find your glowing universe unbearably loud. The fan in your room hums softly, grounding you, and you imagine it as the zoo's background noise, the steady breath of countless universes whispering at once, each hum a different law, each vibration a different equation singing in its own tongue. The sound doesn't overwhelm you, it lulls you. The zoo may be infinite, but it rocks you like a chorus, each universe adding its own note to the cosmic lullaby. And then you chuckle at the idea of favourites. If universes are animals, yours is a rare bird in the aviary, feathered just right to balance on its perch. Somewhere, a physicist's version of you in another pen might be peering through the bars thinking the same. How odd, they'd say, that my universe turned out this way. Both of you marvelling across cages you'll never cross, yet sharing the same wonder. Historians still argue whether multiverse theories belong to science or philosophy. The zoo is vast, but no ticket booth exists, no map you can hold. Some say it cheapens our universe, making it just one animal among countless others. But here, as you drift deeper, the zoo doesn't feel cheap. It feels abundant. It means existence isn't fragile, it's overflowing. For every barren cage, another sings. For every dark pen, another glows. And in this one, you find yourself alive, listening, dreaming. You close your eyes and let the zoo fade, not as a place of cages, but as a forest of possibilities. Branches, bubbles, branes, tunnels, flows, all blending into one great menagerie. You don't need to wander every pen, it's enough to know they're out there, humming their strange songs, existing in their strange ways. The zoo surrounds you, infinite and unreachable, but tonight it's just another lullaby. The zoo of universes fades into the distance, its strange cages and odd equations dissolving into quiet. For a moment you're left floating in silence, suspended in the vast bubble of your own cosmos. And then a new thought arrives. Not about countless other universes, but about your own. What if this universe isn't unique, not even in time? What if it lives, dies, and is reborn endlessly like a cosmic phoenix? This is the dream of cyclic cosmology, a universe that repeats itself, collapsing and bouncing back forever. You let the idea wash over you, slow and rhythmic. Expansion, collapse, rebirth. Expansion again, a heartbeat on the scale of eternity. Some ancient cultures already imagined it. Hindu cosmology speaks of endless cycles of creation and destruction, universes woven and unwoven like threads in a loom. The Stoics of Greece believed the cosmos burned itself up in a fiery end, only to be reborn exactly as before. Modern cosmologists, with their equations and satellites, simply wrapped these old intuitions in new clothes. The thought itself is timeless. Historians still argue whether cyclic models hold up against the evidence of accelerating expansion. Right now, the universe isn't slowing down, dark energy is stretching it faster and faster. If that keeps up, no collapse will ever come, but the theories evolve and some suggest that dark energy itself could reverse, turning expansion into contraction. The cosmos, after growing vast and thin, might someday fall back inward, galaxies rushing together in a big crunch. From that collapse, a new explosion, a new Big Bang, could spark, a cosmic bounce, and the cycle begins again. You picture it vividly. The stars around you drift apart, farther, fainter, until the sky grows empty. Then slowly, gravity reasserts itself. The galaxies turn back, streaming inward like raindrops down a window pane. Collisions multiply, heat builds, the sky glows not with points of light but with one all-consuming force. And then, silence, a pause, a rebirth. The light flares again, a new universe bursting outward, filled with newborn galaxies. You open your eyes and the cycle begins anew. Here's a quirky tidbit. In 2002, physicists Paul Steinhardt and Neil Turok proposed a version of cyclic cosmology based on branes. In their model, our universe exists on one brane and another brane floats parallel. Every so often the two collide. The crash releases energy, sparking as a new Big Bang. Universes bloom, expand, fade, and then the branes collide again. Think of it like cymbals clashing over and over, each crash echoing as a cosmos. Your whole existence, perhaps, is just one beat in that infinite rhythm. You chuckle softly at the drama of it. Imagine explaining to your neighbour that the universe is just two cosmic sheets slapping together every few trillion years. It's nothing personal, you'd say, just branes doing their thing. But beneath the humour, the idea carries comfort. If the universe cycles, then endings aren't final. Death isn't a void, but part of a rhythm, a pause before the next verse. Historians still argue whether a cyclic universe would ever repeat exactly, or whether each cycle would be slightly different. Some suggest everything resets precisely, down to the smallest particle. That would mean you, this moment, this very bedtime story, would happen again and again. An infinite loop of déjà vu. Others argue that entropy builds each time, ensuring no cycle is identical. Maybe next time galaxies form differently, life evolves along another path, and you never sit here at all. The cycles continue, but each is its own improvisation. The fan in your room hums steadily, and suddenly you hear it as a cosmic metronome, ticking off cycles. Whir. Expansion. Whir. Collapse. Whir. Rebirth. The rhythm lulls you, steady and eternal. You breathe with it, your chest rising and falling in sync, as though your body itself is part of the cosmic cycle. Perhaps it is. Every breath an expansion, every exhale a collapse, each inhale a rebirth. You imagine drifting through countless cycles, watching universes burn and bloom like fireflies. At first it feels dizzying, too big, too endless, but soon the scale becomes comforting. You're not trapped in a single fragile universe. You're part of a rhythm older than time, a dance that never ends. Even collapse becomes less frightening when you know it's followed by renewal. Another smile creeps in as you think of the grand irony. Modern cosmology often paints the universe as doomed to heat death, an endless stretch of expansion where stars fade, energy disperses, and nothing stirs again. But cyclic models rebel against that bleakness. They whisper, no, endings are beginnings in disguise. The universe doesn't fade into silence. It keeps the beat, clashing cymbals, pulsing heart breathing in and out forever. And isn't that the essence of rest? Not permanence, but rhythm. Sleep follows waking, waking follows sleep. Your own little cycle echoes the great one, reassuring you that pauses are never the end. They are simply part of the flow. Tonight's rest is just one collapse, tomorrow's dawn one more rebirth. So you let the rhythm rock you, eyes heavy, breath slow. The universe may be a straight line into entropy, or it may be a circle, forever collapsing and blooming. You don't need to know. All you need is the thought that endings are never final. That time may loop like a lullaby on repeat, carrying you gently into dreams. The rhythm of collapse and rebirth still echoes in your mind, galaxies expanding and contracting like a chest breathing in the dark. But soon a very different idea sneaks in, playful and unnerving in equal measure. What if there is no collapse, no bounce, no multiverse zoo at all? What if the universe isn't out there in the way you think? What if it's a program, a grand simulation running on a machine beyond your comprehension? A cosmic video game where you, galaxies and black holes are nothing more than lines of code. The thought makes you smirk at first. It sounds like science fiction, like the kind of thing whispered over late-night pizza after watching The Matrix, and yet serious philosophers and physicists have entertained it. The argument, in its simplest form, is this. If civilizations ever become advanced enough to run detailed simulations of universes, then they might run millions or billions of them. If so, the odds of you being in the single real universe instead of one of the countless simulated ones are vanishingly small. In other words, statistically, you're probably just code. Historians still argue whether this is philosophy disguised as probability or a genuine scientific hypothesis. Nick Bostrom, the philosopher who formalized the simulation argument in 2003, didn't claim to know the truth. He simply laid out the logic. Either civilizations never get advanced enough to run simulations, or they choose not to, or you are almost certainly inside one. The trilemma has haunted late-night dorm rooms and physics forums alike ever since. You imagine it now, floating not in empty space but in a rendered environment. The stars around you, pixels, the galaxies, complex algorithms painting spiral arms with elegant precision. Even the hum of your fan back in your room could be part of the simulation. White noise generated to keep your mind grounded. The idea should unsettle you. But instead, you chuckle. If reality is simulated, at least it's a beautifully designed one. Whoever coded it has a fine eye for detail. Here's a quirky tidbit. In 2012, a group of physicists seriously proposed looking for pixelation in the universe as evidence of simulation. Just as images on your computer reveal their grainy pixels if you zoom in too far, maybe the universe reveals a grid at the smallest scales. They suggested analysing cosmic rays, high-energy particles from space, to see if their behaviour hinted at a lattice-like structure. So far, nothing conclusive. But the very fact that scientists proposed it shows how the simulation suspicion has crept into serious thought. You drift further into the thought, picturing the outside not as another universe but as a server room. Rows of humming machines, fans spinning, lights blinking, an IT department for existence itself. Somewhere perhaps, a graduate student in a higher universe is running your cosmos as part of their dissertation. Universe 117, the label reads. Parameters: carbon-based life, 3 spatial dimensions, 1 time dimension, dark energy variable set to 0.7. They sip their coffee, glance at your galaxy and think, not bad, let's let it run a bit longer. Historians still argue whether such speculation is testable. Some think glitches in the laws of physics, tiny inconsistencies, could reveal the programming beneath. Others argue the programmers would design the simulation too perfectly for that. Then there's the more chilling suggestion: if you ever did prove it, the programmers might shut it down. Best not to poke too hard at the walls of your cage, they say, in case someone notices you've caught on. You sigh softly at the humour of it. Imagine living your life worrying about being deleted like a corrupted save file. Yet here, at the edge of sleep, it doesn't feel frightening. If you are simulated, then everything you've loved, laughed at, or wondered about still feels real to you. A simulated kiss warms the same. A simulated galaxy glows just as bright. Existence, whether coded or raw, still rocks you gently toward dreams. Another funny thought crosses your mind. Maybe dreams themselves are glitches. Moments when the simulation wobbles, letting random scraps of code fire off in your brain. Or maybe they're Easter eggs, little side programs built in to keep you entertained. Tonight's story, wandering across universes, poking at horizons, could be exactly that. A scripted side quest in a larger simulation. And here you are, dutifully playing your part. The fan in your room hums on and suddenly you hear it as the server hum, the cooling system of reality itself. Each vibration is a reminder that the simulation continues to run smoothly. The steady sound soothes you, as though the programmers themselves are tucking you in. You're stable. The code is running. No crash tonight. Historians still argue whether it matters at all. If you are simulated, does that make your universe less real? Or is it real, just a word for the framework you inhabit, whatever its source? Some philosophers argue that even if you're inside a simulation, it's reality for you. You can't step outside, so for all practical purposes, this is the realest real there is. The server room beyond, if it exists, is no more relevant to your day-to-day than the wiring inside your phone is relevant to the text you send, and that perhaps is the most comforting part. You don't need to solve the simulation suspicion tonight. Whether you're code or atoms, whether the stars are pixels or plasma, the wonder feels the same. The galaxies still glow, the universe still hums. Your pillow is still soft, so you let the suspicion drift away, not as a threat but as another lullaby. Maybe the outside is a server room, maybe it's something stranger. But inside, in your bubble, it's quiet, it's warm, and it's enough. You close your eyes, listening to the hum of both fan and cosmos, and smile. If this is a simulation, then it's a beautifully restful one. The suspicion of being inside a cosmic server room lingers for a while, its humming fans blending with the one in your own room, but soon it fades into something gentler. You realise you've wandered past the reach of equations, telescopes and experiments. Out here, at the outer rim of thought, science loosens its grip. numbers blur, instruments fall silent, and only philosophy dares to tiptoe further. The questions grow softer, stranger, more personal. What does it mean for a universe to have an outside? What does it mean for you to be here at all? Philosophy has always lurked at the edge of science. Long before telescopes, thinkers tilted their heads at the night sky and asked questions that still echo. Aristotle imagined celestial spheres, crystalline shells holding planets in place. Kant speculated about island universes, long before we confirmed galaxies beyond our own. Even now, when physics builds equations that stretch across chalkboards, philosophers ask whether those equations describe reality or only our mind's best metaphors. You can almost hear them whispering in the background, reminding you that no matter how far you drift, wonder is not measured in light years but in perspective. Historians still argue whether philosophy is a handmaiden to science or its foundation. Some scientists roll their eyes, muttering that philosophy adds nothing but wordplay. Others insist science itself can't exist without philosophical scaffolding, concepts like logic, causation, or even the assumption that nature is consistent. Without those, equations would crumble like sandcastles. You imagine them arguing in circles, but the debate feels less like conflict and more like a lullaby loop, repeating endlessly to keep the mind busy while the body rests. You drift now into the oldest philosophical question of all: why is there something rather than nothing? If science explains how the universe evolved, philosophy asks why it exists at all. Some say nothing is unstable, that existence is inevitable. Others argue the question itself is meaningless, like asking what lies north of the North Pole. You breathe slowly, letting the paradox unsettle. It doesn't demand an answer, it only invites awe. Here's a quirky tidbit. The German philosopher Leibniz was one of the first to phrase the something rather than nothing question so bluntly. Centuries later, physicists still wrestle with it. Even quantum theories that conjure universes from fluctuations don't explain why the quantum field exists in the first place. You chuckle at the thought, centuries of progress, yet Leibniz's question still lingers like a mosquito you can't quite swat. Another thought arises: what is consciousness in all of this? You float past galaxies, bubbles, branes, yet your own awareness is the one thing you know directly. Descartes famously said, "Cogito, ergo sum, I think, therefore I am." But what is this I that drifts through universes in your imagination? A cluster of neurons firing in patterns? A simulation subroutine? Or something more fundamental, a spark woven into the fabric of reality itself? Historians still argue whether consciousness is an emergent property of matter or a basic ingredient of the cosmos, as essential as space and time. You recline deeper, feeling the hum of your thoughts slow. Consciousness may be the only window you have into the outside, the only candle you can carry into the dark, and yet even that flame flickers with question. When you sleep, does your awareness vanish? Or does it dissolve into a different kind of being? If other universes exist, does your consciousness split with them? Are there infinite yous, each aware only of their own branch? The thought should tangle you in knots, but instead it loosens you, like untying laces before bed. Philosophy doesn't offer final answers, only better questions. Some thinkers embrace that, treating questions as companions rather than obstacles. You imagine them sitting in ancient courtyards or dim cafes, sipping wine, gazing at the same stars you gaze at now, content to let mystery linger. In a way, they were doing what you're doing tonight, letting wonder rock them toward calm. The fan in your room hums on, steady as ever, and you imagine it as the voice of philosophy itself, constant, background, never fully noticed until you lean in. Science is the telescope, sharp and dazzling. Philosophy is the hum reminding you that even with the clearest view, there are always horizons you cannot cross. Both together form the lullaby of human thought. Another smile creeps in as you think about the playful side of philosophy. Ancient skeptics once argued that maybe the entire world is just a dream of a butterfly, or maybe nothing outside your own mind exists at all. These ideas weren't meant to depress. They were meant to free you, to remind you not to cling too tightly to certainty. In the same way, tonight's journey isn't about grasping every answer. It's about letting go, floating with the questions, allowing mystery to become comfort. Historians still argue whether the universe has meaning, or whether meaning is something only humans invent. For some, the sheer vastness implies indifference, a cosmos too large to care about your tiny life. For others, The fact that you can ask the question at all gives it meaning. The universe becomes aware of itself through you. You lie there between these two poles, not choosing, just drifting, content with the ambiguity. And that perhaps is the true gift of philosophy at the edge. It doesn't demand closure, it doesn't slam the door with finality, it leaves it ajar, really, letting questions breathe like fresh night air. You don't need to decide whether the universe is purposeful or purposeless, finite or infinite, simulated or real. You only need to know that wondering is part of being alive. So you rest now, your eyelids heavy, surrounded by galaxies you'll never touch and questions you'll never solve. Philosophy rocks you gently, whispering not answers but possibilities. Beyond science, beyond proof, beyond even imagination, mystery remains, and that mystery, soft and endless, is enough to carry you into sleep. The philosophical hum drifts softly around you, its questions trailing off like smoke, and into that silence comes something older, warmer, more human. Long before physics, before telescopes, before equations scribbled across chalkboards, people still looked up at the sky and asked the same questions you've been wandering through tonight. They didn't have cosmic microwave backgrounds or inflationary models, but they had stories, grand, playful, terrifying myths about what lies at the edge of the world and what waits beyond. You imagine yourself sitting by a fire thousands of years ago, surrounded by people whose only telescope is the naked eye. Above them, the stars gleam with impossible clarity. To them, the heavens are not a puzzle of galaxies and cosmic radiation. They are a canopy, a dome, a tapestry woven by gods. Beyond it, that's where imagination takes over. Take the Babylonians. Their mythic cosmology pictured the earth as a flat disk floating on waters, with the heavens arched above like an inverted bowl. Beyond the bowl lay more waters, a boundless sea. The gods themselves held back that ocean, and if they ever faltered, the flood would come crashing down. To step beyond the edge of the world, in their view, was to plunge into endless water. The Norse had their own version, Yggdrasil, the world tree. Its branches stretched into the heavens, its roots curled into realms of the dead, and its trunk bound everything together. Beyond the tree were giants, serpents, and the frost of chaos. To them, the edge wasn't a place but a state. Beyond the ordered branches lay wildness, unshaped and unknowable. You smile at the image, picturing yourself dangling from one of those roots, peeking into the void while the great serpent Jörmungandr coils in the distance. Historians still argue whether myths like these were meant as literal maps or symbolic frameworks. Did the Norse truly believe in a cosmic ash tree? Did the Babylonians picture an actual dome? Or were these metaphors, ways of giving shape to feelings of awe that even modern cosmology hasn't fully explained? Either way, the stories worked. They offered comfort, order, and a sense of belonging in a cosmos that felt vast even then. Here's a quirky tidbit. The ancient Egyptians believed the goddess Nut stretched her body across the sky, arching over the earth with her star-studded skin. Every night she swallowed the sun, and every morning she gave birth to it again. In their view, the edge of the cosmos wasn't a wall or void, but the goddess herself, embracing and recycling creation endlessly. It's an image far more intimate than galaxies and branes, yet it hums with the same rhythm of birth and rebirth you drifted through earlier. You recline in your imagination, letting the myths flow past like dream fragments. The Greeks spoke of chaos, the primordial void from which everything arose. The Maori told of Rangi and Papa, the Sky Father and Earth Mother, locked together until their children pried them apart, creating space for light to enter. The Chinese described the giant Pangu, who split the heavens from the earth and held them apart until his death, his body transforming into mountains, rivers, and clouds. Each story paints the cosmos as fragile, ordered only by the will of gods, heroes, or giants. Beyond the edge always lurks chaos. To cross that boundary is to leave safety behind, to risk dissolution. And yet, the myths are not just warnings, they are invitations to wonder. They tell you the world has limits, but your imagination doesn't. Beyond the dome, beyond the tree, beyond the goddess, there lies something vast enough to inspire awe. The fan in your room hums again, and suddenly it feels like the fire crackling in one of those ancient circles. You are one of the storytellers now, spinning tales of bubbles, brains, and dark flows. If someone from those days could hear you, they might nod knowingly. "Ah, yes," they'd say. "Your great attractor is our serpent, your cold spot, our bruise from the gods' quarrel." The names change, the language shifts, but the impulse is the same. Humans cannot resist peeking at the edges. Historians still argue whether modern science has truly replaced myth, or whether science has simply become the new storytelling. Equations, after all, are symbols, not unlike gods and giants. Both try to tame mystery, to give it a shape. Both are told and retold around our modern campfires, lecture halls, podcasts, late-night whispers like this one. And perhaps both serve the same purpose, to soothe us when we realise how small we are beneath the stars. You smile at that realisation. Tonight, as you float through galaxies and theories, you are both scientist and storyteller. You use physics when you can, myths when you beard. Each gives you a different lens, and together they weave a lullaby strong enough to rock you towards sleep. So you let the myths drift with you. The dome of heaven still arches overhead. The world tree still stretches its branches. The goddess still swallows and gives birth to the sun. Beyond them all, something vast still waits, something unknowable yet comforting. You don't need to define it. You only need to let the stories wrap you like a blanket, warm as firelight, soft as whispered legend. The fire of ancient myths glows faintly in your imagination, but as the embers fade, you feel the modern world returning. The dome of the goddess gives way to the dome of an observatory, its roof splitting open like a mechanical flower to reveal the night sky. Where once people peered with naked eyes, today we build instruments, vast gleaming machines designed to catch whispers of light from the edge of time. And even as you drift towards sleep, you realise that the future of these machines may pry open the veil of mystery just a little further, tugging gently at the threads that guard the outside of our universe. You picture the James Webb Space Telescope first, humanity's newest cosmic eye. Already it has peered deeper than Hubble ever could, unveiling galaxies so ancient they formed mere hundreds of millions of years after the Big Bang. Its mirrors gleam like golden petals, delicate yet powerful, unfolding far beyond the reach of Earth's atmosphere. With infrared vision, it can pierce dust, peer through cosmic fog, and reveal the baby steps of stars and planets. And though it wasn't built to answer what lies beyond the universe, every new image feels like a small step in that direction, an expansion of the horizon of wonder. Historians still argue whether Webb's discoveries challenge our models of galaxy formation. Some of its first images showed surprisingly massive galaxies forming far earlier than expected, shaking assumptions like loose gravel. Are our theories wrong, or is the universe simply stranger than we thought? The debate hums, playful yet profound as new data pours in. You smile at the thought that even billion-dollar machines can leave scientists scratching their heads like philosophers by the fire. Beyond Webb, the future holds even more ambitious eyes. You imagine the Nancy Grace Roman Space Telescope planned to map the sky in wide swaths, hunting for the subtle effects of dark energy. Roman will measure how galaxies clump and drift, giving us sharper clues about the mysterious force that drives cosmic acceleration. If we ever hope to know whether the universe will expand forever, collapse back, or cycle endlessly, Roman's wide gaze may be the key. And then there are ground-based giants rising like temples, the extremely large telescope in Chile, with a mirror nearly 40 meters across. The giant Magellan telescope, its 7 huge mirrors combining into one, the 30-meter telescope, a colossal eye planned for Hawaii. Each of these observatories will gather more light than any telescope before, their vision sharp enough to glimpse exoplanets directly, to watch the dance of stars around black holes, to probe structures near the horizon of our cosmic cage. Here's a quirky tidbit. Astronomers joke that telescopes are time machines. Because light takes time to travel, every glance at a galaxy is a look into the past. The bigger the telescope, the further back you see. In that sense, future machines aren't just opening new windows, they are building longer corridors into history, hallways that stretch closer and closer to the moment of creation. One day, perhaps, they may even brush against the very first light, the instant when the universe itself blinked awake. Historians still argue whether even perfect telescopes could ever show us what lies beyond the horizon. By definition, light from beyond can never reach us, but clever minds keep finding loopholes. Gravitational waves, for example, ripple through space itself. Instruments like LIGO and its successors may one day detect waves from the earliest moments of inflation, carrying information that light cannot. Other projects dream of neutrino telescopes, vast detectors buried deep in ice or ocean, sensitive to ghostly particles that slip through matter like whispers through walls. These may give us glimpses of realms photons can't touch, You imagine yourself standing among these machines, wandering through a forest of metal and glass. Domes swivel, mirrors tilt, lasers shoot into the sky to correct the blur of atmosphere. The telescopes feel alive, like cosmic flowers blooming in unison, all turning toward the heavens. You tilt your head with them, gazing not just at stars but at questions. What lies beyond the cosmic curtain? How far can our machines push the horizon back? And will we ever know if other universes brush against ours? The fan in your room hums steadily, and you picture it as the combined whir of all these telescopes, all their motors and sensors humming together in a chorus. Each hum is a promise that curiosity doesn't stop, that even in your lifetime, new eyes will open wider. You breathe with it, letting the thought of steady progress soothe you. Humanity builds one telescope, then another, each larger, each sharper, each daring to tug at the veil. Another smile sneaks in as you think of the less serious side of astronomy. Telescopes are often delayed, budgets balloon, politics intrude. For decades, Hubble was nearly cancelled, Webb faced endless jokes about slipping deadlines, and even now, giant ground-based telescopes spark controversies about land and funding. And yet somehow, the machines are built, the mirrors are polished, the domes open. Against all odds, human curiosity proves stubborn. Like a child who keeps asking why long after the adults have grown tired. Historians still argue whether technology will ever let us see beyond the observable universe, or whether the horizon is absolute. But even if the horizon never budges, telescopes will keep showing us more detail within it. They'll find Earth-like planets in nearby systems, map the large-scale cosmic web with unprecedented clarity, and perhaps even detect signs of life in alien atmospheres. Beyond may remain mystery, but within will grow richer every year. So you will recline, eyelids heavy, comforted by the thought that the story doesn't end here. The veil may never fully lift, but humans will keep tugging at its threads, pulling gently, unravelling patterns one by one. Each telescope is a hand on the curtain, each image a peek at what was hidden. And though you may never see the other side, you are part of the species that keeps trying, keeps building, keeps dreaming. You let that thought settle, warm and reassuring. The future holds bigger eyes, sharper lenses, deeper maps. But tonight all you need is the hum of curiosity, the promise that wonder never stops. You close your eyes, and the telescopes keep watching for you, their golden mirrors tilted towards the stars, their domes breathing open in the night. The telescopes close their domes in your imagination, mirrors folding like golden petals, and you're left once more in quiet darkness. You've drifted through so many possibilities tonight. Bubbles brushing together, brains colliding, mirror universes unwinding time, quantum branches splitting like trees, cosmic currents tugging at galaxies, myths of domes and world trees, servers humming with simulated skies. Each theory, each story, each whisper has carried you closer to one realization. The edges of the universe are not where answers live. They are where wonder remains. You rest in that thought, letting it expand like a slow breath. Science may map galaxies and measure radiation, but even its most brilliant minds admit they cannot say what lies beyond. Philosophy may craft elegant questions, myths may spin beautiful tales, but none can dissolve the mystery. And maybe that's the gift. If the universe handed you its secrets plainly, tied up in neat boxes, curiosity would die. Wonder thrives in not knowing. Historians still argue whether humanity's quest for cosmic truth is destined for completion, or if mystery is eternal. Some optimists believe that one day, with better instruments and sharper equations, we'll glimpse the full picture. Others insist that horizons are fundamental, that some answers are sealed forever. The arguments ripple across journals and conferences unresolved, but here, in the quiet of your own drifting thoughts, the debate doesn't matter. Completion or mystery, science or story. The important thing is that you are alive to wonder at all. You smile softly, eyelids heavy, as you realize that curiosity itself is the constant. From Babylonian priests watching stars trace across their dome, to modern scientists analyzing faint cosmic hiss, to you now, nestled under blankets, humanity has always shared the same lullaby. We look up, we ask, we dream. The cosmos doesn't need to answer, it only needs to inspire. Here's a quirky tidbit. Carl Sagan once said that to read a book is to perform a kind of time travel, letting thoughts of people long dead whisper in your mind. Tonight you've done something similar with the universe itself. letting photons billions of years old whisper across your imagination, letting ancient myths breathe again, letting equations and speculations hum together in your ear. You've turned the cosmos into a bedtime story, and that story is older than words. The fan in your room hums steadily, no longer a server or telescope or cosmic current. Now it is simply a sound, soft and familiar, blending with your breath. The universe doesn't feel like a puzzle anymore. It feels like a companion, vast and quiet, rocking you gently. You don't need to decide whether it's infinite, simulated, mirrored or cyclic. You don't need to solve the cold spot, the great attractor or dark flow. You only need to close your eyes and let the questions keep you company, because that's where wonder remains, not in answers, but in the spaces between them, in the pause before a theory, in the flicker of static on an old TV, in the hush of myths whispered by firelight, in the hum of telescopes opening their eyes. Wonder is the thread connecting it all, binding science, story and dream into one seamless kind of fabric. And that fabric, like the universe itself, stretches beyond every horizon. So you let it stretch around you now, soft as a blanket, endless as night. You drift not toward answers, but toward calm, not toward certainty, but toward peace. The cosmos waits beyond the veil, unknowable, untouchable, but here within you, its greatest gift glows steady, the ability to wonder, to imagine, to dream. And now, as the journey fades, let the pace slow even further. The galaxies, the bubbles, the branes, they all soften into distant shapes, blurred and harmless, like lanterns drifting away across a lake at night. You don't need to chase them anymore. You don't need to stretch across horizons or peer into tunnels. They drift on without you, and you remain safe here, wrapped in stillness. Your breath deepens, slower, gentler. Each inhale is a tide rising, each exhale a tide falling. The fan hums steadily, no longer a stand-in for cosmic mysteries, but simply the sound of your own little corner of the universe keeping time. You realize that all the vastness you imagined tonight, the galaxies, the dark flows, the endless zoo of universes, has folded down into something small and tender. You, lying here, body at rest, mind at ease. There's comfort in knowing that mystery stretches forever. You are not tasked with solving it all. You're only invited to rest within it, to let curiosity remain a quiet ember glowing in the background while your thoughts soften. The questions will still be there tomorrow, patient and timeless. For now, you can let them go. Picture the universe as a great dark ocean, calm and still, dotted with faint ripples of light. You're not lost in it. You're floating, gently supported, the water cool and endless, the stars distant but kind. There is no hurry, no pull, no demand, only drifting, only breathing, only rest. And as the last of your wakefulness slips away, know this: whatever lies on the other side of the universe, it cannot follow you here. Here you're safe, here you're still, here you can sleep.